Let's take a look at our short answer section. They ask us for the x-coordinates of the function m of x. So m of x was 3x squared plus x minus 14. To find the vertex, we're always going to use our negative b over 2a formula. So we just need to substitute in for that. Here is a, here is b, and then here is c. There's a. B is going to be that imaginary, that 1 that's right there, and then c is going to be negative 14. So we're going to substitute into this formula negative b over 2a. Our b value again was 1, and then 2a, so 2 times a. This is negative 1 over 6 is our final answer. We want to find the coordinates of the intersection points of m of x and p of x. This is your key to put an equal sign in between the two functions, m of x and p of x. M of x again was 3x squared plus x minus 14, and p of x was 12x plus 6. To find where these two equations are going to equal each other, we're going to subtract 12x and 6 from both sides, and this will get us a function that equals 0. So we have 3x squared, and then this is minus 11x. This is going to be minus 20, and then that equals 12 minus 12 is 0, 6 minus 6 is 0. So that's a good thing. We want our function to equal 0. When I look at the factors of 20, there's 2 and 5, and 1 and 20, and that is 4 and 5, and then 2 and 10. There's no combination here that I can use of my factors to add up to 11 here. So what I need to do is factor using the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. All of that will be divided by 2a. Again, you're going to use your ABCs. There's your A, there's your B, and then there's your C. So A equals 3, B equals negative 11, and C equals negative 20. Let's substitute in to this formula. We have negative B plus and minus the square roots of b squared minus 4 times a times c, all divided by 2 times a. Okay. So let's take a look and see how we can simplify this. A negative and a negative will give us a positive. So this is going to be 11 plus or minus. And then here on the bottom, 2 times 3 is just 6. Okay. So let's see what we can do here. 11 times 11 is 121, and this is a negative that's squared, so a negative times a negative will give you a positive. And then 4 times 3 is 12, and 12 times 20 is going to be 240, plus 240. Again, negative times a negative will give you a positive. So 121 plus 240 is 361. And that's good news for us because that is a perfect square. The square root of 361 is just 19. So this whole thing, I know it looks a little messy, but the whole thing simplifies down to 11 plus or minus 19 divided by 6. So let's rewrite that. 11 plus or minus 19 divided by 6. And then we'll split out into two different answers. The first one, you're going to do 11 plus 19. 11 plus 19 divided by 6. The second one, you're going to do 11 minus 19 divided by 6. 11 plus 19 is 30. 30 divided by 6 is 5. So one of your solutions is going to be 5. And then this will simplify down to, let's see here, a negative there. So this is negative 4 over 3. That's your final answer there. Okay. So our two solutions, x equals 5 and x equals negative 4 over 3. Okay, so j of x is divisible by x minus 3. Determine all real roots. So we need to divide. j of x is 4x cubed minus 12x squared plus 16x minus 48. So 4x cubed minus 12x squared plus 16x minus 48, and then we'll divide all of that by x minus 3. Take your coefficient here and write it up at the top, and then we'll reduce our 3 exponent by 1. So 3 minus 1 gives us the 2 that we're going to write up here. 4x squared times x is 4x cubed. 4x squared times negative 3 is negative 12x squared. When we subtract, we're going to flip the sign, and this will give us a 0 for that. You can bring down the 16x, and then you can also bring down the negative 48. You're going to take this number here, 16, and you can write it up here. And then you're going to reduce your exponent by 1. So this exponent right here will go away. 1 minus 1 is 0. So we're just going to have a 16. 16 times x is 16x, and then 16 times negative 3 is negative 48. When you flip your sign to subtract, this will cancel out to 0. So you have your two factors that you know of right now. You have x minus 3, and then you have 4x squared plus 16. Those are two factors that you can count on. So let's take a look at how we can solve out this final factor. So right now what we do know is that x minus 3 multiplied by 4x squared plus 16 is going to give us this entire equation, right? So all we did was divide. So if we multiply, we should get the original back. This whole thing is going to equal 0. So x minus 3 equals 0 is our first factor. If you add 3 to both sides, you're going to get x equals 3. That's one of your roots. Let's try the other one. 4x squared plus 16 equals 0. 4x squared plus 16 equals 0. Let's subtract 16 from both sides, and you're going to get 4x squared equals negative 16. I already know something is going on right here, strange, because I have negative on this side. I'm going to divide by 4, and I'm going to get x squared equals negative 4. When I take the square roots of both sides, the square root of x squared is x, because x times x is x squared. And the square root of 4 is just 2. But the square root of negative 1 here, this negative sign, the square root of negative 1 is imaginary. So this is going to be a plus and minus 2i root for you. So that's going to circle out. And so there are your 3 roots that you have here. You have x equals 3 and x equals plus or minus 2i. You should have 3 of them, and you know that because the original function that you were working with was 4x cubed. And this cubed means that you need 3 factors. 3 roots. Letter D says evaluate the function k when the function j is at 1. Evaluate the function k when j equals 1. So let's evaluate j at 1, and then we'll evaluate whatever that comes out to be, then we'll evaluate at k. So j of x, j of 1 equals 4 times 1 cubed minus 12 times 1 squared plus 16 times 1 minus 48. So 1 cubed is just 1, so 4 minus 12 plus 16 minus 48 is where we're going to start. And let's reduce our terms. 16 minus 12 is 4, so this is going to be 4 plus 4, which is 8, and then minus 48. So we have 4 plus 4 minus 48 equals negative 40. Okay. So negative 40 now, we know what j of 1 is. J at 1 is negative 40. And that's this centerpiece. But then they also asked us to evaluate k at negative 40. So let's do that. We've got k at negative 40 equals negative 3 times the absolute value of negative 40 plus 2 and then minus 9. So we just substitute this right into the k equation. Negative 40 plus 2 is negative 38, minus 9 here. And then the absolute value of negative 38 is a positive 38. So this is going to be negative 3 multiplied by positive 38 and then minus 9. So 3 times 38 is going to give you negative 114 minus 9. Altogether, this is going to give you negative 123. And that will be your final answer. Looks like 2 more questions here to go through. So we want to simplify the following expressions as much as possible. The first one is the box method we can use. We can just create an array of 4 plus 2i and 3 minus i. This will give us 12 plus 6i. This will give us negative 4i and then negative 2i squared. So 12 and then 6i minus 4i is going to be 2i, and then negative 2 times I squared. I squared equals negative 1. So this is just saying negative 2 multiplied by negative 1, and that's going to be a positive 2. So 12 plus 2i plus 2, this gives us 14 plus 2i. You want to make sure that you write your I at the very end. The next one that we're going to do then is going to be the cube root of 64 minus the square root of 24 plus the square root of 27 and then plus times the square root of 2. So I think my favorite way of attacking the problem is just separating each independent root out into its own thing by expanding. So the cube root of 64 just means what number times itself 3 times is equaling 64. And 4 times 4 is 16. 16 times 4 is 64. So this whole expression simplifies down to 4. We have the square root of 24 here. The factors of 24 are 4 and 6. I chose 4 and 6 because 4 is a perfect square. The square root of 4 is 2. So we've just left here with the square root of 6. The square root of 4 is 2, so this is going to be minus square root of 4 is 2, and then times this leftover square root of 6. Now we're going to factor 27. I'm going to break that out into 3 and 9. I chose 3 and 9 because 9 is a perfect square. The square root of 9 is just 3, and I'm only left with multiplying by the square root of 3. So this is going to be plus 3, and then we have the square root of 3 times the square root of 2. So let's simplify next line. 4 minus, and then we have 2 square roots of 6 plus 3 times the square root of 3 times the square root of 2. So the square root of 3 times the square root of 2 is the square root of 6. So this is 4 minus 2 square roots of 6 plus 3 square roots of 6. They did this as kind of a gift because now we can combine these like terms. If we have the square root of 6 over here and the square root of 6 over here, we just need to add up the first numbers. 3 minus 2 is just 1. So now you just have 1 square root of 6, 4 minus 1 square root of 6 is your answer. There you go. The very last problem, they give you a parabola and they ask you to graph it. A couple of things you know, this negative sign means that it's a reflection. The negative 2 means it's been shifted right 2 units. And the plus 9 is up 9 units. You also know the vertex, it's right here. It's positive 2, comma, positive 9. So vertex at positive 2, comma, positive 9. I'm going to create a little table off to the side as well, just for a couple of extra coordinate points before I start graphing.